Hey guys, 6.7, using the fundamental theorem algebra. I'm holding your book in because we're going to look a bit at page 366. Just to remind you what we did in class, we talked about how many solutions does an equation have. And it always tells you, and we talked about this in class, that that exponent will tell you exactly how many solutions does an equation have. So this is x to the fifth. I'm looking for 5 solutions. If you look at example 1, equation that is x to the third plus 3x to the second, etc. X to the third tells me I have 3 solutions to that equation. If I look at part B of example 1, x to the fourth tell me I have 4 solutions. Now, keep in mind, we talked about this last year, and we talked about this in class. If I have a graph that looks like this, and it touches that and changes direction, right there, that means that is a double solution, okay? Because that would be, let's pretend this is 2. This is x minus 2 all squared, or x minus 2 times x minus 2. How do I know that? Because in that point, it changes direction. So if it just touches the x-axis to give me a solution, and then it changes direction, that means that's going to be a double solution. Also, because we already done chapter 5, we know there's such things called as imaginary solutions, right? So not only do I have what I can get out of my graph with where it touches, but then sometimes we're going to have extra solutions that are the I solutions, okay? So depending on how you look, if you look at a thing and it's asking you how many solutions does it have? 5. How do I know what those solutions are? Well, the easiest way to do it, instead of doing it the way the book teaches you, is to graph it. I already typed it in on y equals 1. I'm going to go zoom 6, and I get my graph. Why? Because it's going to give me at least 2 solutions of my equation. If you look at that, it touches at -2, so I already know x is -2 is my solution. And it also touches at 1, and it changes direction at 1, which means I know that I get x equals 1 and x equals 1 twice, which is great. I already have 3 numbers to play with, right? So if I'm going to go ahead and do that, I'm going to play with synthetic division. I already know what I'm going to divide by. I just need to find out what my next polynomial is. Let's go with this. That's a 1. 1, -2. I'm missing x to the third. That makes it a 0. Positive 8. -13. Positive 6. Remember, I already know that by the time I'm done, I'm going to end up with a big fat 0 here, because either one of these are going to be solution. I'm going to do 1 first. I'm bringing the 1 down. I get 1 times 1, 1. -2 plus 1, -1, -1, -1, -1, 7, 7, -6, -6. When I add them up, 0. I stopped saying we've done this enough in class. No, we add them, right? -6, 0. So my new polynomial is now, forget about this. I'm going to go ahead and erase this. I know I'm starting with x to the fourth now. I'm going 1 down, and it becomes 1x to the fourth minus 1x to the third minus 1x to the second plus 7x minus 6. And I already know that my initial polynomial has an x minus 1 as a solution. Not only that, but I can redo this and divide by 1 again, because I know 1 is a double solution. I used one of them. I'm going to do my synthetic division again. I don't have to add a 0 this time. 1, -1, -1, 7, -6. 1 comes down. 1, 0, 0, -1, -1, 6, 6, big fat 0. I get another x minus 1, correct? Now, my new polynomial is, I use this one, I can cross it out. My new polynomial is, I had the fourth, now I'm going to the third. I get 1x to the third. I do not have an x to the second. I can write that plus 0x to the second. It's going to help me with the thing. Minus 1x plus 6. I'm going to do this again. The third division. I know you're not going to be a fan of this, but this is how it works. I'm doing my last synthetic division. The only one that's left to divide by is a -2. Okay. Oh, quick reminder, why do I put as a -1? Whenever they go into the parentheses, it's going to be the opposite of this, right? So if x is 1, that means 1 minus 1 is 0. That's why. Let's put this 1, 1, 0, -1, 6. I already know this is going to be 0. I know because that's a solution. 1 comes down, -2, -2. This becomes a +4, 3, -6, 0, right? So my final thing, this is x, the opposite of that, plus 2. And I can write the final one here, x, 1x squared minus 2x plus 3. Okay? Why am I not doing another synthetic division? I used all of these. I don't have another solution, right? So I only have two options going from here when I look at the bottom. Yes, sir. I'm going to rewrite it up here for you to see how that works. So I'm looking at x squared minus 2x plus 3, and I need to know what the solutions of this is. Well, if you look at this and you think of two numbers that times to a positive 3 and they add to a negative 2, they don't exist. There's only two options. Either negative 1 times negative 3 gives me a positive 3, or 1 times 3 gives me a positive 3. There's our only option. When I add them, I get a 4 or a negative 4, which means I have to do the quadratic. I by now can tell you for a fact that we either going to get an irrational number or an I. I don't know what we're going to get. A is 1, B is negative 2, C is 3. Quadratic formula says x equals negative b, negative negative 2, plus or minus square root of negative 2 squared, minus 4 times 1 times 3, and all of it over 2 times 1. Right? That's where we are right now. So let's go ahead and see what we get here. We get a positive 2 plus or minus square root of, this becomes 4 minus 12. I get a negative 8 all over 2. Clearly, this is an I. We cannot have a square root of a negative number. Also, I can think of 8 as 2 times 2 times 2, or as 4 times 2, whatever helps you better. So this becomes 2 plus or minus. I have two 2's on that 8. 1 can come out. 1 stays in, right? That's the one I didn't cross out. All over 2. And if you remember, I told you if you have a 2 and a 2 over there, you can go ahead and factor 1 out. 1. 1 plus or minus I root 2, right? 2 divided by 2, 1. 2 divided by 2, 1. I square of 2 all over 2, which cancels that one out. So my last solutions for these equations are 1 plus or minus I square root of 2. These make 2 of the solutions. We had 3 over here. Altogether, we have 5 solutions. Okay? It's a lot of writing, not a hard work to do. So on example 2, it says find all the zeros. The zeros are negative 2, 1, 1, 1 plus I squared of 2, 1 minus I squared of 2. There's 5 of them always. You always have to have 5 because that's what that leading coefficient initially, when we had it, we started with x to the 5th. Okay, that's just how it works. Now, hey guys, example 2. Find all the, example 3, sorry. Here's your information about that polynomial. A equals 0, your leading coefficient, A equals 1, leading coefficient is 1. One of my solutions is x equals 2. My other solution is x equals 1 plus I, which we talked in class. This means you automatically get a second solution, x equals 1 minus I. The conjugate of it is also a solution. How do we write this? F of x equals A, x minus k, x minus h, x minus, I don't even care, L. We have 3 solutions, right? So we're going to plug all of these in. This becomes A is 1, I don't have to write it down, x minus 2, x minus 1 plus I, x minus 1 minus I, right? Let's go ahead and open parentheses. X minus 2 times x minus 1 minus I times x minus 1 plus I, right? Now let me ask you this. This is going to be a long way to do it. You can just do it one by one and then one by one. But if you look at this, I can rewrite this as x minus 2 parentheses times x minus 1 minus I, and then x minus 1 plus I, right? I can just group them. And look at this. I have a minus 1 and a plus 1. This is the formula I'm going to use. This becomes x minus 2 parentheses x minus 1 all squared, this is an I, minus I all squared. That's the formula. My A in this case becomes x minus 1 and my B is I, right? All I had to do is write it the right way. Let's go ahead and finish this. This is a lot of work. I know. You're going to hate this. We're going to get over it. X minus 2. This is a formula. I can either do 4. I'm not going to bother with that. Or you can apply the formula. This becomes x squared minus 2x plus 1. And I squared is negative 1, right? Which means minus minus 1 becomes a plus 1, which makes this a plus 2. The last thing that I need to do is go ahead and distribute everything in here. This becomes x squared times x minus 2 minus 2x times x minus 2 plus 2 times x minus 2. This is just busy work. X to the third minus 2x to the second minus 2x to the second plus 4x plus 2x minus 4. And the last thing, and remember, I did this really fast. What am I doing? I'm distributing, right? Negative times a positive, a negative. Negative times a negative, a positive. Right? We always pay attention to signs. All I have to do is group. I only have a 1x to the third. I have negative 4x to the second. I can get rid of them. I have a plus 6. I can get rid of them. And a negative 4. If you look in the book, that's the answer we got. Long process. We're not going to stress about it. You do not have a lot of homework like this. You probably have at least one problem like this. Now remember, this was a difficult one. How would an easy one look like? And this is not in the book, but I'm going to show you really fast because I want you to understand how this would work. What if I would tell you the exact same thing, but I would tell you my other solution is 3i. Well, I also immediately know negative 3i is a solution. The conjugate of it will be a solution, right? So this becomes x minus 2, x minus 3i, x plus 3i, which really we like a lot better working it this way, because this becomes x minus 2 times x squared minus 9i squared, right? Based on that formula, this becomes x minus 2, x squared plus 9, because I squared is negative 1, and all I have to do now is 4x to the third minus 2x to the second plus 9x minus 18, and I'm done. And I'm thinking your homework looks like this and not like the example we just worked on the board, okay? Now, before we're done with this, we're going to look at some stuff that you are going to like about this lesson, and that is how to approximate zeros. F of x equals x to the fourth minus 2x to the third minus x to the second minus 2x minus 2. Now, as soon as you hear the word approximate, you should know we do not have any perfect solutions, which means all I have to do is go to my calculator, introduce this over there, minus 2x, I messed up, to the third, minus x to the second, minus 2x, minus 2. Okay, I put it all in here. I'm going to go zoom 6, because I want to see what am I going to get with this function. And if you look at it, it's very clear we're not getting any exact solutions, right? Now, here's what I do know for a fact, okay? I know I need to have 4 solutions. And if you look at your graph, that means that we only can get 2 real solutions out of this, correct? There's only two places where this graph intersects the y-axis, which means I already know I have 2 imaginary solutions. I don't know which one they are, but I do know they are. So how do we do this? We're going to first zoom in. I'm going to go zoom, option 2, hit enter again to zoom in, and we're going to get at least one of the solutions out. The other one is not in our reach. We're going to have to move. So now we're going to just do a trace. We're going to move our little dot until I get to where it touches. Actually, let's do second calc. We want to find that 0, right? Option 2. And it's going to ask you, what is your left bound? You want to move just right on top of it and hit enter. And then you want to come all underneath it and hit enter. And then you're going to ask it to guess. And one of my solutions is x equals negative 0.73. So one of my solutions is x equals negative 0.73. Okay? I need to find the other solution, right? Let's go ahead and zoom out. Zoom, number 3, hit enter. We're going back right where we need to be. And now I'm going to have to move my little dot closer to where that things intersects, right? Because I need to know that value. And now I can go zoom to enter because I want to know that value. And I'm waiting for it to pop up. There it is. And again, I'm going to go second calc. I'm going to go to option number 2. Hit enter. It's going to tell me what is your left bound. We're going to move until we see the left bound, which is right underneath the graph. That's my left bound. Okay, I'm going to move it up and I'm going to tell it that's my right bound. And it's going to ask me, do you want me to guess it? We said yes. And my solution to this one is x equals 2.73. Have you noticed that? 2.73. I'm making sure that the book says the same so we don't go crazy. We do not know what other zeros are. So from here on, I would say 2 imaginary solutions. You could go ahead and do the hard work and use this synthetic division and find the solutions. We're not going to do that. So from here on, whenever you hear on your homework that says approximate, remember, we're just looking for the zeros that we can read. And then once you get 2 of them out, you go, what is my leading exponent? 4. I found 2 zeros. I have 2 more that have to be imaginary, and you stop right there. The last thing we're going to look at is the word problem on 368. Again, we have a nasty problem here. It talks about something test at Harvard. I'm going to put this polynomial in 0.6x squared minus 2.4x plus 19. I wanted to do that first so I can get stuff out of the way. So they're telling us that their S score has that model right there, and X is the amount of hemoglobin in the blood, and they say the normal range of hemoglobin is 12 to 100 grams per 1 millimeters of blood. Approximate the amount of hemoglobin for a person who scored a 75. So first things first, we want to graph that function, right? We're going to graph that function, and really what we're looking for is for the 0 of that function. I put it in here. I'm going to make my window x minimum 0, x maximum I have no idea what to make. I'm just going to put 25. I'm winging it at this point. My y minimum is going to be 0. My y maximum, I don't know. I'm just going to put 50 for now. I'm really winging it. And I'm going to graph. I don't know what we're getting. Oh, here it is. We're not doing good. This tells me that this is crossing something else somewhere else, and I don't know where it is. Let me make sure that I have, I know. X third plus 0.6 second minus. It's because I graphed the wrong thing. I already know the amount of thing in the blood. The score is 75. So really, I don't have a plus 19, but I have a plus 19. Let me put parentheses just because I'm lazy. Minus 75. Okay, that's what I'm looking for. Let me graph again now. We're going to get a completely different story in our graph. Here it is, right? It's now pointing me exactly where I need to have. I forgot to write this as 75, I know the score, equals negative 0.015 x to the second plus 0.6, this is the third, minus 2.4 x plus 19. So in order to solve this, I need to move the 75 on the other side, right? Minus 75 and equally to 0, which really this becomes negative 56. That's what I forgot to do. We did this in class, so this should come back to you. And now all I need to know is what is that 0? Well, that's going to be pretty easy. I'm going to go second calc. I'm looking for my 0. It's going to ask me what is my left bound. I'm just going to guess it. What is my right bound? I'm going to have to bring my little dot to where I can see it. I'm going to say right there. Do you want me to guess? And it is 16.42 or 16.4. X equals 16.4. That's what the book says. Mine is 4.3. Same thing, right? That's what we're looking for. We're just looking for that 0. The other way to do that, if you didn't want to do that, would have been you should just graph it. Once it graphs, if you just move your little dot, you bring you make your y 0, and you move your little dot, you can get that 0 out. You can also make your y minimum -3, just for the sake of this graph, and that way you can actually, although we are in real life world, you can now play with your little dot and bring it where you need it to have, and not stress about, oh, I can't see it, right? And I can bring it all the way I need it to be. Here it is, 16.4. Same thing, okay? That is 6.7. Good luck with your homework.